Hi, 6th grade. Welcome to Tuesday. Here we are on Tuesday. Today we have a couple of things going on. First thing is you have a page for your interactive notebook. So we're going to learn about the Euclidean algorithm today. And that algorithm was created by this man, Euclid. So what I want you to do for today is you guys are going to look up these facts, when he was born and where, when and where he died, his family, any character traits about him, interesting facts, his significant contributions to mathematics, and then on the other side, his education, important influences, famous quote, universities or important places that are named in his honor, label the continents where he lived and worked, what his area of focus was, and any awards and honors that he received. Tomorrow, during our Zoom call, we will go over these answers, okay? And then I will post that video so that you can check your stuff. Also today, after you've done that, there's a pop-up template, all right? And so here, in number 1, name, birth and date, what he's most famous for, a moment in time, an important event during his lifetime, perspectives, okay? Then a famous quote, now what advice would he or she give today? A little bit of thinking there. And then on the back, draw a visual representation of the life of this historical character. Just like everything in our interactive notebooks, solid line means to cut, dotted lines mean to fold. So this is like an accordion pop-up of Euclid. Okay, this here is where you would glue it or tape it into your notebook, and then it pops open. All right, so you guys get to do those two things today, and then we're going to go over lesson 19 right now. So lesson 19 is all about the Euclidean algorithm. I want you to go ahead, I'm going to read these, and then you guys need to pause it, get these four steps, I should say, for the Euclidean algorithm down in your notebook. So step number 1, we're going to divide the larger of the two numbers by the smaller one. I should tell you that this is to find the greatest common factor. Hopefully you'll have learned about this already when you do the interactive notebook pages. So greatest common factor of two numbers. That's what we're doing, which is what we've been doing. But when our numbers get really big, this is a nice way that we can solve for that greatest common factor. So step number 1, we would divide the larger of the two numbers by the smaller one. Step number 2, if there is a remainder, divide it into the divisor. Step number 3, continue dividing the last divisor by the last remainder until the remainder is 0. And finally, the final divisor is the greatest common factor of the original pair of numbers. Okay, go ahead and pause the video, get those written down into your interactive notebook, and then come back and join me. All right, welcome back. This will all make a lot more sense after we do a couple of examples. So, example number 1, what is the greatest common factor of 60 and 100? Greatest common factor of 60 and 100. That's what we're going to try and find. A lot of us can already figure this out in our head at this point in time, but let's go ahead and look at it as far as the Euclidean algorithm. So, let's go ahead and draw this visually. Okay, go ahead and draw this visually. So let's say if we wanted to have this be as an area model, this would be a 60 by 100, right? This would be a 60 by 100, and we would be trying to find the area. Okay, so if we did this, we would say we'd have 20, 40, 60, 80, 100. So if each of our squares was a 20 by 20, okay, so this is a 20 by 20 inch square, 20, 40, 60, 80, 100, 20, 40, 60 going this direction. Okay, so notice that we can use the greatest common factor of 20 to create the largest square tile that covers the rectangle without any overlaps or gaps. Okay, so we used a 20 by 20. Okay, What if we didn't know that? What if we didn't know the greatest common factor was 20? Well, we could say, we could start by guessing what is the biggest square tile that we could make. Square tile. All right, the biggest square I could do would be a 3 by 3, which if each of these is 20, that'd be a 60 by 60. All right. It fits, right, if we were doing a 60 by 60. Okay, but there's still these that are left over. Okay. So then the leftover area would be 60 by 40. All right. I promise it'll make more sense as we keep going through. I know some of you are like, wait a minute, what? But we're gonna show it and do it. So here we go. Let's go ahead and start with the Euclidean algorithm. I'm gonna go ahead and keep this there so we can have that for reference. All right. So the first thing we want to do is step number 1 said divide the larger of the two numbers by the smaller one. So I'm going to divide the larger of the two numbers by the smaller one. Okay, so 60 goes into 100 one time. My remainder is 40. Step number 2, okay, if there is a remainder, divide it into the divisor. Okay, so that's where this came from. If we had a 60 by 100 and we divided that, and we said, all right, well, if we started with this 60 by 60, how much is left over? Well, here we would have the 40, all right? So then we can take, all right, well, let's take that 40, okay, and we're going to divide that. So it says if there's a remainder, this is my remainder, we're going to divide that into the divisor, I should have written these closer together, sorry. So we're going to divide that into the divisor, and we're going to get a remainder of 20. Okay, now we're going to repeat the process. We're going to take that remainder and we're going to divide that into this divisor. And we're going to end up with 2. Okay, so then it says step number 4, the final divisor is the greatest common factor of the original pair of numbers. The final divisor is the greatest common factor of the original pair of numbers. So up here, the greatest common factor of these is 20. Okay. I hope you guys can see where all the numbers came from and went. So 60, we took 100 divided by 60, we were left with 40. This was my remainder. That remainder became my divisor. I divided this original divisor came here. So then I subtracted, my remainder became my new divisor. My other divisor became my dividend. Okay, we'll do a couple more examples, and I hope it'll make a little bit more sense to you all. All right, so example 2 says, let's find the greatest common factor of 30 and 50. 30 and 50. Step number 1, divide the larger by the smaller. So we divide those. We get a remainder of 20. Okay, this 20 becomes my new divisor. My original divisor now becomes my dividend. Okay, my remainder becomes my new divisor. My old divisor becomes my dividend. 10 goes into 20 2 times. And there we have it. My last divisor is the greatest common factor. Greatest common factor of 30 and 50 is 10. All right, let's jump over to this harder one. Let's do 660. Greatest common factor of 660 and 840. 840. All right, we're going to divide these two numbers. Okay, 840 divided by 660. Okay. And here we go. Sorry, my phone is ringing over here. 180. So 180 becomes my new divisor. My dividend is my old divisor. Okay. So now 180 into 660, we find out would be 3 times. 0, 24, 5. Subtract and you get 110. 110 becomes my new divisor. 180 is my dividend now. That will go in 1 time. Something's wrong. I didn't do my math right. 6 minus 4 is 2. You guys would have caught me on that. Yes, you would have. Thank you. So then I subtract here, and I would get 60. This becomes my new divisor. The 120 becomes my dividend. 60 goes into 122 times. Greatest common factor of 660 and 840 is 60. There is a problem like this on your test. Okay, so you do need to know this process and how to do it. Let me find your packets. See what else there is for this lesson. So lesson 19, here you are. Use the Euclidean algorithm to find the greatest common factor. Okay, here it tells you they're planning a party. They order a rectangular sheet pizza that measures 21 inches by 36 inches. They tell the pizza maker not to cut it because they want to cut it themselves. All pieces of pizza must be square with none left over. What is the side length of the largest square piece into which Juanita and Samuel can cut the pizza? How many pieces of this size can be cut? Okay, you're going to have to think about those. Give you something to work your brain today. Shelly and Mikkel are making a quilt. They have a piece of fabric that measures 48 inches by 168 inches. Okay, same kind of thing as up here. And then you have the exit ticket. 1 question there. All right? So that should not be too difficult at all. Now, that's going to take us through Tuesday. All right? Tomorrow, we'll do on our Zoom call, we're going to go over the trifold that you're going to do today. This is also going to be your day to get everything caught up. All right? So, make sure all your study islands are caught up. This one, letters B through D are due. A was due last Friday, so get those in to me, okay? But this is kind of your day to make sure all of those are caught up and do some reviewing. You'll have your test tomorrow on Thursday, okay? And then Friday, we're going to start a brand new unit. It does look like a ton of work in your packets, but it is so easy, and I will be going over the videos with you, all right? All right, as always, reach out if you have questions. Thanks, guys.